Hello, everyone. I'm here. It actually, I'm not sure if actually the audio is working today, so if you don't mind, let me do a bit of testing, okay? And let me see. Oh, okay. Looks like it is working now. I actually have another my other MacBook out there, and I'm like connecting to here, and looks like it is working. Although I think my music isn't quite picked up quite well. Or if it's too loud, let me know, because I really don't know what's going on with my, with all those problems, but I'm gonna fix it. And not only that, actually, I'm switching service for my music, the audio. So um, I was like finding myself paying a little too much, although it was good too that I was using Pretzel and I was then supporting other folks, that are, I think part of their revenue that I gave them actually is quite a lot of money out of my own pocket. it actually goes towards the artist. So sometimes I think that's the thing, right? If we're developers, I'm kind of feeling like we should be feeling we're so lucky in the sense that we do make decent money, at least, right? Most of us, if not all, we make in fact very good money. I mean, if you think of artists, right, they spend a lot of time doing learning their trade. It's not easy. I think it's just that they can't get a job, and it's so difficult. Sometimes I realize that I've come across folks who maybe went to college, and then they are trained as musician, very outstanding ones too. It's not easy. It's like a craft, right? They do music, and then ended up then they can't get a decent job. So then, I mean, as a musician, kind of unfortunate, right? It's only very few who are very fortunate that they become celebrity and they make a lot of money, right? So most of the people don't really have much money doing that. And so I found, people are working as like servers at the restaurant and all that, which isn't nothing bad, but it's like, they spend all their time, you know, uh, studying, learning their trade, and doing performances, all of these things. And if they are performing artists, especially, then you spend all the time, and then but nobody is paying them, and so they need to make a living too. So they go off and do some other work that would pay them money. So it's kind of, we live in a not very fair world, if you kind of think about it. But I suppose that's how things go. It's kind of unfortunate, I think, and think of the fact that okay, we complain, right? We're developers. I mean, I was a developer for 25 years before I became an advocate, and developers, we felt like, oh, gee, we're being mistreated, all these things, and yeah, we're at the mercy of the business, so to speak. I mean, they kind of use us at their disposal, so to speak. But we have our trade too. Our trade is that we write code, and we, it's in some ways it's like artists too. We are kind of code slingers. Sometimes people are being called, we sling together all the code. And the fact is that at least I think if we work hard, we be able to get paid. You can become a freelancer, get paid by the hour, contractor, consultant, or full-time employees. We all be able to do, make a living, or at least not starving. But really, seriously, some of the musicians that I've come across, you see them performing on the streets, and it's just so sad, right? And they otherwise not be able to get a decent living, so they have to do other things. So anyway, okay, so how I got to here was because I was talking about the music. And like I said, I was subscribing and using Pretzel, that other music provider, for live streaming all of the music there. If I play it, they are DMCA free, or DMCA, or digital music, some agreement, right? Kind of clause. They are like not violating DMCA essentially. So all like, license, kind of free to use, without having to pay royalty free music, so to speak. I think there are many way of describing them, but I think you get what I'm trying to say. So anyway, so today I'm just playing some music that they are royalty free, I hope, right? So because otherwise too, I think my stream would be blocked too. But those are music that I got, then they are kind of free to download. And not sure how good it comes through, because that's what I was kind of being delayed, because I was trying to set it up, because on Pretzel I'd be able to say, how I want set my input and output, the channels and everything, because I also have a driver that's there. Then I can send it to the driver, so my OBS can pick that up and play it on the stream. But then now I'm just playing it on my Apple Music, and I cannot find the channel setting. So, or unless somebody can tell me how to do it. And I actually also downloaded Spotify too, because I also have Spotify, but I couldn't find where it is. So, but anyway, I'm just playing the music, as it is being picked up by my microphone here. So if it gets too loud, let me know. And if you can't hear me, if somehow I forgot, about, and kind of somehow checking my audio, if you can't hear me, well, of course, if I'm saying it now, and then if you don't, if you can't hear me, what I'm saying, then you don't know what it is. But anyway, you get it, right? If you see me kind of talking and there's no sound, then please tell, kind of go to the chat dialogue, and let me put it like that. Let me kind of type it out. Hello. Um, in case, you my voice isn't audible, please, please shout, please let me know. Thank you. Yesterday, so I should say that yesterday my audio was botched somehow. Well, it's actually in OBS. Somehow it drops that configuration because I configured to my external microphone, but somehow it lost. So I didn't even know, and I recorded the whole session like an hour and a half. Felt like, that's why I'm using a title that described this as a soliloquy. So soliloquy, right? And that's how it's called, meaning that I am just saying things out loud just to myself, right? Just talking to myself. Soliloquy. Soliloquy? Yeah, I think that's the word to use. Anyway, so hopefully today isn't so bad. So that's what I was trying to say. So, um, anyway, so I basically too was thinking, what would be good, right? Especially now in this still kind of 2023, kind of still sort of the beginning, kind of second month of the year. I'm kind of like making myself a goal for myself is that I'll do more actual life coding than it is with me sometimes just talk or doing some things that are more like, using an interface to help me to do it. I mean, there's nothing wrong, like kind of like no code or low code. But the idea is that we're all developers. I mean, assuming that you are or you are interested in it. So let me do more coding too. And it also will help me because I actually have to, admit that since becoming an advocate, I actually did not have much time to do coding, believe it or not. And that's because as developer advocates, we go out and we, speak at conferences, we speak with folks and meet a lot of people, which is something I enjoy so much, tremendously. And I think I enjoy it so much that I did not give any time to do much coding, and shame on me. So I haven't been doing as much. And I think I did a couple, did some of it, let's put it that way, during the pandemic when I was doing the Twitch stream from the IBM developer stream, right? And but then since then, and I don't know how I got into the travel time again, and then I lost track of time, and I'm not coding, so it's not very good. And so it's like if I'm trying to be in shape, right? Training as an athlete, I need to be running every day rather than just talking about running. So that's the thing, right? So all right, so bear with me. I'm gonna have a couple of episodes in which I'm very, very rusty, but I'm going to try to kind of get back to all that coding and more coding, and then you guys can participate too if you're interested, right? And and of course, without saying anything, is my good friend Josh Long, and some of you, if not all, right? And he's such a celebrity developer advocate at VMware, at the former Pivotal and VMware Spring, right? If you're a Java developer, most of you know Spring, right? Or have used it, and such a a popular framework out there. So Josh been doing advocacy for Spring for quite some time, and he's just amazing. And I think yesterday too, I was gonna say, right, like my today my when I started the stream here, the cover page is actually a picture of Chicago, because Josh is actually, I don't know if he's still in Chicago, but he was here because he had to go visit a customer here in Chicago, and he invited me to join him too. And that was like the evening, their social hour after he gave a talk and all of these things. And so that was very nice. And so that's how I got to see him. And so that was just very nice to see him. So I invited him. I said, Josh, come here and do some coding for me. And I can also kind of basically help me along, kind of get me into the mood of doing coding. So that's what I'm going to, that's my plan, right? If not right away, we'll be, in starting to do more is what it is. And if you want to see something, let me know too, right? So, okay. So, and let me kind of double check, making sure my sound is still good. Nobody is saying anything. So let me kind of take a look, and, all right, so let me. Okay. Okay. All right. It's kind of funny to see myself right on the other Twitch client that I have on my other Mac. It looks like I can hear myself talk. So that's not too bad. Okay, here we go. So let me then get back to what I was trying to do yesterday with the sound being muted. I was trying to talk about CDC. So, CDC, like if you are in the US especially, I'm not talking about the US Health Department or controller, Center for Disease Control. Not that. I'm talking about change data capture. And yesterday too, actually, I also kind of brought up, right? Change data capture is actually an interesting fundamentally not too complicated. If you compare with other things in terms of the complexity is actually not, if you kind of break it down, it's not like a too complicated design pattern, right? You implement things using that pattern. And let me kind of quickly show it to you again, right? If you folks you already know about it, then bear with me. So let me kind of do this one thing. Let me kind of get my I have what we call a slide deck because I just did a talk too. Let me kind of like get out of the way so it won't be blocking you. So give me a second. All right, here we go. So I'm in here, I'm in Elasticsearch, but let's kind of get into, oh, no, not this. Okay, this is actually my new talk, by the way. It's just going to talk about Apache Pulsar and Apache Kafka. So you get a little preview of this slide deck, but that's not what I'm looking for. What I wanted to show is basically a talk that I recently did at JFocus, and that's a Java focused developer conference, although there are other things too, other topics too, but it still started off Java users group in Stockholm that run the JFocus. So as you can see, so the date too as such, is only, I spoke on the 7th. So exactly 10 days ago, I did this talk. So just wanted to like share with you too, maybe, for those of you who are interested, right? And if kind of do a slideshow, event-driven change data capture pattern using Apache Pulsar. So the point is that the one thing is that there's that pattern, right? It is a design pattern. And you can implement it, as such as an architectural pattern, and you can implement it any way you want. But what we're suggesting is that how about using an event-driven type of approach? So let's kind of take a really quick look. Again, if you already know it, then bear with me for a second, especially for those of you, maybe if you are, new to programming, wanting to, kind of hear about some things, right? And I mean, the thing is, though, if you're completely brand new to coding, you probably aren't starting. Oh, wait, actually, over here, you won't be like starting with just doing this. This is more like about, change data captures as a design pattern. And actually, I have some kind of over here. It's interesting. Okay, I realized too that I actually have set up my theme in here, so I hope it's not blocking. Yeah, it looks like it's okay. All right, here we go. Event-driven change data capture. I'm not going to do a presentation, but just wanted to show a couple of key points. So then it's kind of it will serve as an introduction. So, all right, so that's me. And here we go. Let's not worry about that. But basically, too, I wanted to talk about things is like why change data capture, right? What's the purpose, right? Sometimes we like to do things, yeah, it's maybe it's kind of an interesting thing, we want to do it. But the thing is, too, we do need to question the fact that why are we doing something, right? What's the purpose? So basically, CDC is to help to its purpose, right, is to serve as like data sources. And you might say, what are data sources? If you're new in here, it means that they are source of where the data comes from. So it can be from data at rest, which is like at storage, which is databases. It also actually can be file system too. It actually also, I suppose, if you want to have a socket, right? A socket is where, you are like receiving, is basically an endpoint receiving some kind of data that flows through it. That can also become a data source, right? It doesn't have to be necessarily database, but very often, though, in today's world, we're referring to databases as, mostly the data sources. So databases, files, data lakes, data lakes are like really for doing more the traditional way of gathering, data into lakes, and that's how it's described, right? It's kind of like pools of data, essentially. So data lakes or data warehouses. Warehouse are essentially database or data that's kind of after processing, you want to save them, right? It's like a warehouse full of data. So those are kind of like data sources that we are change data capture pattern can be applied to. So essentially, too, I highlighting in here is that the action on it is to detect any kind of changes to your data, and capture the changes. If you detect there's some changes, you capture it, and then from there, you may or may not need to transform it. Sometimes, too, you can capture some data and essentially say, okay, I want to capture the changes, and I probably want to transport it down to downstream, right? Any kind of downstream data system. So what we're going to do today, though, I'm going to be demonstrating is using CDC. It's basically uh, watching for any observing, kind of monitoring some database column. So if there are data changes in that column, we'll be adding another, set of row of data or something, it will trigger some kind of action. And then in that case too, our exercise is going to be very simple rather than complicating it and adding in transformation kind of thing. We aren't doing that today. We're just gonna like take the change and essentially sends it downstream, and we're just gonna try it. You might have noticed I'm gonna try it out with sending it over to an Elasticsearch endpoint. So now Elasticsearch, for those of you who are maybe new to it, is Elastic is the company that makes Elastic, is a search engine. The search engine, I believe, is like originally, let's take a look too. I think they are like originally, hold over here. No, where did it go? Okay, I think it's actually over here. Okay, let me kind of un maximize it. Let's take a look. Elasticsearch. So Elasticsearch, right? Elastic is the company. So essentially, too, I think this one they actually are, it's actually a very important tool because its strength is it's doing searches in ultra fast kind of fashion. You're building index, right, in various indices you want, right, and into your data source, the data that comes in, and then you want to do fast search. So it is a very popular search engine if you're new to it, right, and especially in the enterprise space, right? Meaning like big companies, we're dealing with huge amounts of data, trading, whatever you name it, right? So it's essentially is Elasticsearch. So essentially, this exercise will be like capturing any kind of changes and then send the changes down to downstream, which is an Elasticsearch endpoint. So that's what we're going to do. So that's why too over here I have set up an Elasticsearch, and yesterday too, I think maybe yesterday's episode didn't go through. So basically, I've set up my Elasticsearch over here, and then we can essentially use that endpoint as the receiving side. Yeah, so that's what it is. So, all right, so let's get back to a bit of a discussion. I'm not going to kind of run. This isn't a presentation, and sometimes people do get allergic to presentations, isn't it? If you're developers or something is like too formal or something. But that's not what I meant. Sometimes in order to talk about something new, we do want to have a bit of an introduction. So otherwise, too, it can be confusing. So, okay, so I already talked about CDC. So let's go over here. And just as very simplified illustration of CDC, right? So what it is that like I said, right? It sense, right? It's observing, like watching, right? Some data source can be a database. This example, using this cylindrical shape thing usually represents some sort of data source. In this case, could be a database, right? They're got disk in there. Data source, and you capture any kind of changes. You actually first, is like you detect, actually, you know what? Let me do this because that's what it's meant to be, right? You have different kind of objects in the picture. So first, detect changes, right? So you need to have some mechanism to detect, right? To kind of observe any kind of changes. And then it's basically watching what you say, watching what is watching your data source. You might, for an example, we can basically say we watch some column in your database, right? Watch for any changes. So if there is insertion, in deletion, modification, it will be, it will send the changes down. So capture it, the second step. You capture all the changes, then you essentially, too, at that point, then you send it over to your CDC engine, whatever it is, right? It, again, is a concept. You can do it the traditional way. You don't necessarily have to do what I'm going to show you too, but what you try to do, using the solution from our company is kind of nice, especially if you use Cassandra as your data source, right? You can actually, is much more easier, because in the past, what you do is maybe you have separate things. You have to set up your data source, right? Uh, some database, and then you also have to have like separate maybe like a program, can be Python, can be Java, a client or something, is basically is like watching the changes, and you may need to poll it, right? Or do some kind of polling, or do some sort of like, way of observing, is kind of watching any kind of changes, and you have to keep watching it and all that. So it's a lot of work in there if you kind of think of the detection kind of piece, right? And it sounds easy to say, okay, I have a watchman watching something, but the thing is that you need to constantly do that, and if any kind of changes, you can have tons of changes coming in, and you can build up some kind of back pressure, all of these things. So that's why too we're trying to suggest having some sort of event driven type of way to help you to do that, and that's something I'll talk about in a little bit. So okay, so concept wise, right, detect changes, capture the changes, send it over to this CDC engine, and then at that point you can then do any kind of transformation. Sometimes you might want to say, some changes comes, and I might need to look at the change and compare that value. For example, some data comes in, you might say, maybe some employee or whoever is doing something, you want to look up that particular person, which is represented as an ID. So from there, the ID needs to do, you need to kind of query another system to look up the actual person and some attribute of that person, maybe look him up and say, well, where is he located, something like that. So you need to kind of do some transformation, and maybe in that case you're saying, okay, well, we're doing a bulk change, maybe like we want to say that whoever like move, within a big company, especially, let's say, I'm based in Chicago, and then I really I'm noticing that any kind of Chicago changes, right? And I need to maybe like, okay, how about that? I need to give them a bonus because they've done a great job or something, right? So over there, you can just say, okay, look in that, and then maybe you look up that person, and you look up to see, okay, oh, okay, this person is based in Chicago, and they've done a great job, whatever, and then you want to increase this, give a bonus or something, right? Or kind of, I'm just kind of talking about something like an example, transform, right? Doing something, extract some information. Then from there, you want to send the data down to another system for processing. Maybe, add the bonus, a bonus system, for example. So then in that case, you want to send the data down to another system, right? So that kind of a flow. So that is what we're trying to capture in here for CDC. It's not Center for Disease Control, but change data capture. Okay, here we go. Now, okay, so the propagation is what we're talking about. We send that data to downstream. Okay, so what was there before CDC, right? You might say, well, this pattern, is been actually been used, and it's like, the older system, a traditional way we call it ETL, right? Extract, transform, and load, right? ETL system. And you've very often found them, kind of, they are, essentially, produced by big software companies like IBM, for example, Oracle, they also have ETL. These are like mainframe systems, right? They have all these things, and they tend to be slower. Also, the whole process too is pretty synchronous in nature. So if you're just doing things that are in batch, right, in a system of record, then maybe system of record, you might say, what is that? It's like, for example, right, in your company, we all have maybe a system, of employee record, employee information system. Those are a system of record. Usually there's no need for any kind of urgency to process, right? If let's say I move, I need to update my address, so I fill in the employee information system. All these information that gets sent over to your system of record, your employee system. But because these are not urgent, so we tend to like to gather all of the changes and batch them all up, so to speak, and process them at a later time. Because during the daytime, we want all of your system to be busy servicing urgent requests. There are customer purchasing something in e-commerce, complicated thing. You need to do all these lookup, and all of these other things are more urgent. So you want to batch up all of the less important things, at off hours, and you process those. So anyway, comes back to this, the ETL, extract, transform, load, are usually, deal with like mainframe type of systems or just older system. You have disparate different processes that are, doing a lot of procedural call. They are like not asynchronous call, kind of like RPC, for example, something like that, right? To kind of, kind of like more systematic, but yet kind of slower. And so, okay, so as you can see, right, it tends to be heavier process, and the tools can be expensive. These big companies, they're selling them at a lot of money, right? And lots of people work on it. They're old. Well, I shouldn't say, but it's just kind of heavier and cost more money. So it's also not being able to keep up with the times, right? So some things may be suited for that, but we live in a world that keeps changing all the time. We can't wait. A lot of times too, people want things yesterday, and like that. So we need to have new solutions. So, but let's take a look into the components of a CDC system. So again, right, we're talking about change detection, and then essentially with this change, we capture them. So it's change capture, and then change propagation. But over here too, it's not necessary. It would be a change transformation, right? So any kind of data that comes in, you want to transform them before propagating too. But I think in some ways it's assumed. You can be like in the capture stage, you do whatever transformation you need. So these are kind of like the basic components. Now, also kind of understand that for CDC too, there's like what is called like a log-based system. What are logs, right? So logs are essentially some events you want to capture them at every change, every data, the state changes, you capture them. And so over here, if you kind of look at these, this diagram, the components of CDC: change detection, change capture, change propagation. So lots of things happening. We need to be able to capture these changes. So if you kind of look at this, right, there are some actions, right, changes happening, and cause the table to be updated twice with multiple two rows. This example is to simplify, two rows of data. One, the first one says, I want to come in, and then I set x equals 1, and the other would say set x equals 2, whatever value. This is just an illustration. So now this is the log, right? The log will say, okay, ID number, sequence number of your record, and comes in, it's actually update table set x equals 1 comes first, and then it will be, kind of overwritten by another, process that comes in and says update table set x equals 2. So now then comes time, right? You capture all of the changes, and then you propagate the changes, and you apply these changes to downstream too. Now the thing is too, there's separate things. For logs, we do want to keep track of them. It kind of goes into the new concepts of event sourcing. You want to keep track every time some data change, you want to capture it, and that's kind of more like an event sourcing type of system. But that's the old way, is like transaction log, right? So you can always look up the log to see what is happening at that certain point in time. So, and then basically at the end too of the day, you want to then too much. You want to then apply the changes and then set x equals 2, or first set x equals 1, then set x equals 2. But as such, you send it to the downstream system. That you notice that if downstream system also only keeps one, essentially one copy of your data, at the latest time, at the most recent time, then you always be able, you can only kind of find out that, okay, the current state is x is equals 2, but there's no way from your target data system you'll be able to say what happened before this, because, and then if you need to find out, then you need to look back into the transaction log to see what's happening at any point in time that you're interested in. So that's the case. Okay, so now then let's take a look, right? Modern, we're now getting into like modern times. What does it mean, right? So everybody knows, right, in today's world, we're all talking about cloud native, right? What is cloud native? It's essentially any kind of processes that needs to be able to handle things in the native way for a cloud. And what is native to the cloud, right? Well, okay, cloud is not like there's really cloud. They are essentially the same thing, same servers. In today's time, you can have a Linux server too, can also be a server. And then essentially cloud will be like multiple, right, of these replicas or machines, in your infrastructure. You can have, you need to have cluster, how low balance, all of these things. And so in a complex data center, you can have many servers, and these form, so to speak, a cloud, right? And they all kind of tie together in the same kind of category, so to speak, right? That's cloud. So to be native, and as such too, as you know, right, all of this infrastructure, the nice thing about it is that modern cloud is that you can run, kind of essentially, you don't want to, you don't want to manage all of these systems like it used to, right? It used to be old times, there might be mainframes or whatever, it can be, Windows server with Linux server in your data center. So you need to manage them, right? You need to do upgrade patches. If something goes wrong, change the disk, all of these things. And yeah, you own everything, but you don't pay extra. You use it at your, at your leisure, basically, or not leisure, what you call it. You use it to your heart's content. You don't need to be charged, except maybe paying for your electricity, right? That's running your server. But okay, so for modern data system is that it's calculating every time you access how many reads, how many writes, right? You will be charged too. So anyway, so that's what cloud native is that some system that's kind of native, it knows how to operate, in a cloud environment. How do you kind of deal with, having multiple nodes, that are servicing your system, your cloud, and replication, all of these things. So that's cloud native, right? Okay, so just in a nutshell. And then also too, and let's say, it gets to some kind of like non-functional aspect, is that your system needs to be highly responsive, meaning that if you need something to be sent there, you need sending a request, you want it to respond back quickly too. I don't want to wait, right? And so you need something very responsive, and also not only that, scalable. Now we're talking about a cloud environment. You can decide that, okay, I'm running out of disk, I'm gonna add another set of disk in here. I have another server to manage all of these things. And I'm just kind of giving an example, but at times you could be adding tons of server to your ecosystem. Then you need, basically you want your service be able to scale, right? All of these, and your application to, not only that, right? There's system level, and then also your application too. Your application needs to be able to handle all of the requests that comes in, be able to scale. If you have more requests coming in, let's say, well, what was it a few days ago? Valentine's Day. And guess what? Folks might be, guys, you're like ordering flowers for your ladies. And so all of the flowers.com, for example, they're receiving, e-commerce site receiving a lot of, requests. So then your system needs to be able to handle, your applications too, being able to handle the process, able to handle all of these requests that comes in, without suffering, right? In terms of response time, right? All of these things. And so you want your system to be very scalable. But the thing is, though, you have to be careful too. You don't want to like keep scaling it. And what if, now it's past Valentine's Day, then you don't have as many orders. So in that case, you want your system to be very resilient, right? Or not resilient, it's kind of more elastic, so it's kind of like a stretch. And now you don't need to stretch it anymore, because there's not as many orders. Then you can go back to normal processing time. Maybe you just need 2 servers or something, right, in your cluster, whatever that is. So you need systems that are highly scalable. And then also, not only that, right, and you want system to be resilient too, meaning that if something goes wrong, a node goes down, you want to have, the capability of spinning off another node to replace it, right? Or something, it's like circuit board, right? Something goes off, and you don't want that bad thing to affect the whole thing. So you want it to be able to, your whole system be able to recover quickly. You want the bad parts be able to be completely maybe taken offline and another take over, kind of like that. So it's kind of like that resiliency kind of aspect. All right, so enough talking of that. And so now then, let's kind of take a look, right? We're always kind of talking about data, right? In any kind of system, in order to make something useful, you want to be able to move data from one point to the other. We're talking about transmission of all of the data as messages. So this is actually, well, okay, I'm a little getting a little too excited talking about event driven stuff, but let's take a look at this first, right? So if we're looking at data, it's going to be sent as messages, right? And so what are some of the things that needs to be happen? It's basically reliability and resiliency. It's come back to the resiliency part, right? You want to guarantee, right? Whatever you want to send, you want to have some sort of mechanism of guaranteeing that I'm sending the messages, that message gets over onto the who I'm going to send the messages to. So now, then we need this system to have what is called like quality of service, right? QoS. And these are like dictating like how many times, messages needs to be sent. Is it like only exactly once, or at least once, or like, let's see, exactly once, only once, or actually, okay, only one time, or one or more time, or another one is that you can send it with duplicates too, for example, things like that, right? So these are different levels of quality of service, right? You need the delivery to be guaranteed. And then another thing too, then we're talking about responsive. That means, we want to employ, a mechanism of doing things asynchronously, very lightweight, right? Loosely coupled type of system, right? And so that's kind of a criteria. And also the scalability. How about using a pub sub type of way of doing things, a publish subscribe or producer consumer type of thing, scenario, scalability. And also too, another thing is message ordering. Is it important, right? You can have tons of message being sent at any point in given time, and they can be arriving at different times. They can be out of sequence too. So but in some cases, you have messaging systems that would guarantee the ordering of the messages. So in that case, then it relies on maybe your messages needs to be identified. Each chunk, right, each segment needs to be identified with some certain segment ID. So then, at the receiving end, you can reconstruct the order of the messages, right? So those are kind of things you need to think of, right? In any kind of like messaging kind of systems, you want it to be responsive, scalable, ordering of these things very reliable. Okay, so now then, this is the thing, right? Because of this modern day requirement, it really requires us a paradigm shift, right? So how about taking an event-driven approach? These days, like I said, I actually had the honor of being interviewed by Adam Ben, who's a Java guru, wizard, kind of like up there celebrity guy. And he's not a full-time speaker or advocate, but he's a really great consultant. He knows so many things. Great guy to talk with. I talked with him, got interviewed by him, and so I'm was on his podcast, and one of them already released. The other will be. So we talked about, and actually the second podcast we talk about event driven approach. And basically too, I got excited because I talked to him, I said, the asynchronous way ought to be the way of doing things because it mimics the human beings way of doing things. Like think of the fact that would you be let's put it that way, if we operate like the same way how we do traditional programming, that means, for example, I need something, right? So I would go, let's say in your family, I go to my mom and I said, I need something, and then she could be busy. So she would say, well, I can't service you now. I'm doing something, so wait. So if it is traditional way, that means I will just sit and wait for her until she's ready. Then I will get what I'm asking her. Now, that's a very synchronous way, and that's how we describe why, sometimes you doing things the old-fashioned way is not very scalable at all. You can't have anybody idle. Let's say if I want something, I ask what I want, I go back to what I want, and say, wait, see, you know what? All of a sudden I remember good example would be if you go to shop for at in the US we have you want to shop at the deli counter, right? That's where you get things that are maybe at a supermarket. They make salads, they make you can buy ham, they slice it for you, cheese, all of these things. And very often you go up there as a line of a group of people, so they implement this system of everybody get a ticket. Based on the ticket number, they will call on you, so that so then you'll be serviced, right, in the order as you get there. First come, first serve kind of principle. So that's the idea, right? You take the ticket. Maybe let's say, I got 20 people in front of me. So I'm number 20 and they are servicing number 3, right? Or something. So in this case, I know I got 17 people before me, even though some people might drop. That's not the point. But the point is that I have so many, in front of me. So let me go, while I'm waiting to get my cheese, I'm going to go and get some juice in the juice section. And I come back and maybe they are, kind of will be ready for me. So that's the idea, right? That's what asynchronous is. So going back to Adam, I was just saying that, I just feel, even he agrees. He said, yeah, we need to really be living in an asynchronous world. He said I should, I should have like a nickname and call myself async girl or something. But anyway, so on my Discord server, in fact, that's what I call myself. And by the way, my here, and this is my Discord server in here. So if you are interested in having more conversation with me, it's also on my profile too. But I thought I'd quickly flash it, so just so you know. Okay, I'll flash it again later. So okay, an event-driven approach. Let me go back, and here we go. Wait. All right. So now, well, now I'm talking about Pulsar. I'm not going to talk about much of Pulsar for now because the point is that I want to talk about CDC for Astra DB, and that's what I'm going to get into, right? It's basically, trust me, right? Apache Pulsar is a really, kind of new generation of very cloud native ready event streaming kind of process. Now, again, when we talk about streaming, is so much confusion, but the point is that streaming is basically dealing with lots of events coming in. Events are basically carries with it data coming from some sources. The data, some changes is an event, right? Like that. So we're kind of now then talking about tons of messages. We're going to deal with it. And so here, this one basically, we're talking about CDC, a data table, right? It can be, in this case, it's Cassandra, is our company, right? And Cassandra, and we have this feature called CDC, Change Data Capture. So you basically can observe any columns that you're interested in observing in your table. And then from there, you can say, well, CDC, I want to watch any kind of changes. Then with the changes, it's basically it comes in and to Pulsar, and Pulsar has the concepts of tenants, right? So these are tenants that are kind of your units of your streaming unit. And so over there, the tenant in there will set up these topics, right? So again, just to refresh your memory if you are new to it or whatever. So this is pops up publish subscribe system, completely like detached, not linked to each other. It's more like my job is to produce messages. The other, if I'm interested in receiving it, I'm the subscriber. So publish, subscribe. So how do they communicate, right? So basically, it's rely on the broker, and that's what Pulsar is. Pulsar itself has a runtime, a Java broker, serverless, very efficient too, and it owns all of these topics. So topics is essentially a way of labeling your messages. I can be sending tons of messages out, but I have messages for different purposes. So I call them topic, right? So these topics are owned by my broker. So this is what happens is that every time you set up a CDC for Astra and it gets to Pulsar, Pulsar 2 will essentially set up what is called a data topic. So essentially any kind of changes from that column will be sent over to your data topic, right? Is capture the data changes, and then it will also write to the log, right? So that's our log topic, and that's what it keeps track of all of the changes, right, of your CDC kind of process. And then over here too, right? And you can be essentially doing some kind of transformation, but the transformation you can use, you can use other things too, but we like to suggest you using Pulsar functions. And that's something I will be demonstrating at a future Twitch episode if you're interested in. Essentially too, it's like AWS Lambda, right? You're writing bite-sized kind of small, lightweight functions that will operate on the data that you receive. And then operates, what does it mean? That means you can transform. For example, you can do some filtering, doing some kind of finding aggregates kind of data value or something like that, just an example. So from that, let's say you kind of like do what you need, and then you need to send the data else somewhere, so you're then sending it to a sink. So that's a streaming sink. The sink downstream can be many things, and in fact, over here is just a small example. It can be Cassandra Sync, can be Google Big Data, BigQuery, some Java Sync, right? As you can have just a client to be receiving that, a subscriber, so to speak, right, to receive that. And Kafka Sync too, MongoDB, SQL Server, Snowflake, all of these, Oracle, you name it, MySQL. But the thing is, too, you'll be curious to see what other things. So let me quickly show you. Okay, let me kind of go back in here. Remember that one slide I go through? This kind of presents to you a whole new ecosystem of connectors and clients, right? Over here, all these database, right, is being supported by our CDC, or by Pulsar, I should put it that way. So Pulsar, really nice. And you can write your code, if you are C programmer too, you can do it in C, C sharp, C++, Go, Scala, Node.js, right? All these are supported as well, even VB, Visual Basic, right? So Python, right? And all of these are, being supported. You can write your clients, producer client or consumer client using these language clients, and yeah. And then there's also messaging streaming workflow type of connectors too. So think of kind of like Lego pieces you can kind of plug in, producer, receiver, like that, and then rely on Pulsar, the broker, to deliver everything for you. And not only that, and that's another beauty of Pulsar, is that think of it as like messaging. It keeps track, it persists all of the messages for you. So it's kind of nice. Pulsar has this very nice way of managing all of these log messages, and it won't go away. If you need to go back to it, you can actually use a reader interface to kind of go through and get, some of the messages you have in the past. You need to look up a replay. So that type of stuff. So, okay. So let's kind of go back now. I think I'm talking too much. I shouldn't be doing like presentation here. So I was just talking about this. So this is the CDC. But sometimes it's fun to talk about, right? Okay, so I think then this is where I can kind of finish with this kind of a thing, this part. But let's kind of then go over to our CDC. So you can now kind of go and take a look at this, right? This is like our CDC for Astra DB. Let me kind of share with you. Here we go. So it is CDC for Astra. So I just shared this with you, right? And you can kind of like, if you're interested, right, kind of go in here, and of course you can always, copy it later too. So I'm gonna hide it for now, or you can just search on DataStax and you'll be able to find us. So over here, right, I already explained all of these things. And of course, a lot of fine-grained things we'll find out more as you kind of get deeper into it. But I won't kind of talk through all of this. Please kind of take a look, right? It supports format like primitive data types and Afro too. Afro is like what Hadoop uses, right? That Afro format. So it's basically Astra DB keys are strings, and CDC produces Afro messages that are structures, right? And the conversion for some of these structures will require additional tooling, right? And like that. So, but these are like, it describes the conversion of Afro logical types, and record type is a schema containing the listed fields. And that's what it says, right? So you can have name is like collections. Afro type is an array and basically is lists or sets, right? Like that. So all of these, please kind of take a look. Now, one thing though, wanting to point out is over here. Why am I? Okay, here we go. Let me kind of be a little bigger. Just wanted to point out, right now CDC is a new feature, so bear with us. We're working on our engineering and smart group of people, but we're very lean too, and so we're working on tons of features, and we're improving CDC too, basically. So, but for now, notice that we do have some limitations. If you use it, basically it doesn't manage like table truncates too. It does not sync data available before starting the CDC agent, right? And does not sync data, does not replay logged batches, and does not manage time to live, does not support range deletes, and also CQL. These are the Cassandra CQL columns, names that must match a pulsar primitive type name. So, for example, like int32 or something, and then does not support multi-region. So that's important to multi-region as such, right? It's basically the region where you set up, if you're using Astra as our managed cloud, make sure your Cassandra and the Pulsar streaming, I should say Astra streaming, both, your streaming tenants, they are in the same region, because just for now, it's just a limitation. Again, it will be improved, all of these things. So, okay, so let's kind of like get our hands, into this. How about that? So, all right, let me kind of shrink this back into a normal size. Is that right? Okay. 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 Now, let me then do this one thing, which is like to bring our Astra DB into here. All right, so this is our Astra DB, and as such, right? Let me share with you. Design. Wait, no. Let me kind of share with you Astra. Astra. Okay, so this is the link to use, astra.datastacks.com. You can kind of go, let me kind of move it out of the way over here so you can, okay, so as you can see, the right-hand side is the Astra Managed Cloud first page. And if you haven't already gotten an account, do please sign up for it. You get $25 credit, for free. You don't need to give your credit card. I always like it whenever free things, just use it without credit card. So just give your email address and set up your account using a password. That's all. So in my case, I already have one, so I can just sign in. Oh, wait. Sometimes it's funny. You just kind of click one more time, then it will work. So as you can see, right, the example over here is like basically we're going to create a tenant and a topic right now. So, okay, so in this case, actually, you know what? I have already done it, so I'm not going to take up additional resources, right? So let me kind of hide this. If you haven't already done it, I can share it too. Wait, let me do this, right? The Astra managed cloud, again, I just want to say $25 US dollar per month credit, right? And you get a renewal too. Let me kind of like datastacks.com. Okay, so I just share it too over here. So if you want it, you can look, and let me make sure nobody's talking with me. Did I miss any messages? No, I didn't. So, okay, that's cool. All right, so once you are here, and basically if you follow, right, the example over here, wait. The example here is create a tenant and a topic. So we are in here already, and notice how nice, right? Our new interface, isn't it nice? It used to be kind of older. This is kind of pretty slick. I like it, And like I said, right? If you sign in, you should be able to see this interface right now. So again, you go over here, and then basically create a streaming tenant. Right. So how do you do it is basically go over on the left side, database or streaming. You can actually go to streaming, and then I've already created one. Let's use JFocus Stream, and that's what I use for the presentation. So we can continue using that. And if you want to create new one, then you just follow and do a create stream, giving a stream name, something like ABC, and then remember to your database and your stream your tenant too needs to reside in the same region. So in this case, is I'm using Google Cloud, and I live in Chicago, so US Central One. And then as you can see, it tells you how much it cost over here, which isn't too bad, right? If you're just doing like personal project, it is pretty sufficient. So click on create stream, and then your stream will be created. So in my case, I already get the JFocus stream. Like if you need instruction, is on the left hand side in the other documentation page, right? Ooh, come on, man. Okay, here we go. And so now we've created that. So the next thing we want to do is to create a tenant, create a table. Create table. So how do you do it is you use the same kind of syntax, just like SQL for your Cassandra query language. So how do you do it? Let's go over to my database. So in my case, right, if you want to create a database, it's also as easy as going to your database and then do a create database. And you can create anything. In my case, I've already created a database, so I'm not going to create a new one, but you can create a database, name it something. Make sure, you give a key space. It's sort of just a namespace. It can be any like non-reserved word not already used. And in this case, I have Google Cloud. Also select US Central. That's my region. Create database, click, and you're done. In my case, I've already have one. It's called MG Twitch Demo 1. That's the one that actually I used it previously too for my Twitch. So that's why it's here. And over here too, as you can see, right, there's also, it's pretty nice. You can try things out. And if you need data, guess what? If you need some test data, you can just say load data. And over here, you can upload your own data set, create a CSV file, create your table, or you can do a sample data set too. So we have a couple of samples you can use to restaurant data, Ethereum, NFTs, or movies and TV shows, or load data from your DynamoDB as well. So you could do it too. It gives you all of these things, and then it's basically, you can follow. But in this case, I suggest that you can do some restaurant data. In my case, I've already uploaded some movies and TV shows, that particular case. So so let's go back in here. As you can see over here, if you go up here, there's CQL console. All right, so I believe that my table, I created it and it may not be here. So actually I have my Twitch ks.tbl1. Oh, it is still here. How come then yesterday, I created it last week, it didn't seem, I think that might be a timeout. So anyway, because I don't work on the Cassandra team, there's some kind of, small details. I'm kind of discovering it, so to speak. But anyway, as you can see, I've already created my table here, this test table that's kind of described on the left-hand side, right? So, but you can also follow that. And then at this point, then you can connect to CDC for Astra DB. So how you do it is select the CDC tab, right? And in this case, I've already created this, right? And it's my movies and TV, I've already enabled it. So let's take a look what happened. So as you can see, right, already CDC for movies and TV, I've already set up, this is where I can manage the pipeline and the topics, right, over here. As you can see, I have also, it's actually, I should say, once you set up your CDC, then it will create the data topic, if you remember, right? This is my default data topic in here. And of course, that's the one thing I always thought it would be nice if it actually allows me to do some kind of mapping, right? Like an alias, then it won't be so confusing. But the thing is that's okay for now. You can just use the copy in here if you ever need, this topic name too. So, and then there's also actually the what you call the log topic. Let's take a look and see where log topic is. Why is it not showing? I thought there is. It's a persistent, as you can see, topic is persistent, because the thing is too, there's a, about topics. Again, topics is how you identify, how do you want to categorize your messages. So there are topics, and basically too, you can have persistent topic and also non-persistent. And as the name implies, if it's persistent, that means it won't go away. And if it's non-persistent, it will go away after, it reaches, if you're inactive, past your time to live, kind of like a threshold, then it will be removed. So, and sometimes if you do some kind of testing, if you don't need your topic to be persistent, you can just use non-persistent. So then this way you won't, take up unnecessary space, and you'll be charged too, right? Don't forget that. And so, okay, so this is my topic in here, and I go back to my topic, and okay, oh, here we go. This is it. It's basically too, this is where the topic is. I have actually 6 topics in here. How did that become like that? Let's take a look. So all of these, I think I know, because I think I was doing what you call a demo, and I think I did it again. So now I have 6 because I did it 3 times. So the thing is though, once you do like associate your CDC, with your with your streaming, your tenant, your topic to in streaming tenant, then it will create, a pair of data and then log topic for you. In this case, I have all these, but I should probably clean it up too at some point. So, okay, but why is it 6 and then I have 12 subscriptions? Okay, it's just probably a default, right? My Astra CDC. This is kind of created by default as you kind of associate your CDC setting up your CDC. So, okay. So over here, I've already set things up, right? So you basically just need to enable your CDC on the database, right? And so you basically pick your tenant and the key space and the table name, and then you enable it, right? So this is what I have in here. Now, so that's where I think yesterday I was doing my stream up to this point, and then I get into setting up my sync, right? Remember, we already set up like the front side of things, the producer, basically the source, right? Source of data, and then the CDC setup, for the streaming. So now I get to set up my sync, which is an Elasticsearch sync. So let me then go over to the Elastic and take a look, right? Wait, sorry. Here we go. Elastic. Okay. So this is my Elastic. I think it's a little bit dark in here. Let me turn on my light. I have actually a light in here. I didn't turn it on earlier. Okay. And okay, so a little bit brighter now. And let's take a look. Okay, so this is my Elastic. Is a healthy thing right now. Running, is deployed, running. And so I just need to, that's where I thought yesterday I was setting up an alias, because again, it gives the long kind of unique UUID thing. And I set up the alias, and not knowing the alias took a long time. And then I thought, okay, I'll finish it today. And I actually did not have time to look at it until now. So let's take a look. We're looking into enterprise search in this case. And okay, getting started, create a new index. I don't really need that right now. I'm just using it as a pass-through type of thing. So overview, I think I'm already here. Let's go to settings. Where did I see it yesterday? Deployment wide. Okay, overview. Let's go back here. Maybe it's here. I thought there's also a dashboard that I need to get to. Is it Elasticsearch? Okay, these are, okay. My deployment is here. Manage. There we go. I think that's where this is. I need to get to my dashboard, and then I'd be able to get the yes, this is where it is. And so as you can see, yesterday I was setting up my endpoint alias called mg deployment. So from there, it's actually making it a little easier. Otherwise, you got that long string, that long UUID thing. So I set up mg deployment. And so what I can do at this point is that I can take my Elasticsearch, I can copy the endpoint. This endpoint can then be used, for my Elasticsearch, set up for this for the sync side. So let's go back over here. Okay, so we can take a look at this over here. So I have already added my Elasticsearch sync. I think I have, right? Have I? And let's go over to sync. Oh, I have not. Actually, you know what? Let me take a look first. This one, how do you get to? I created my CDC connector, then connect this Elasticsearch sync to it. So, oh, let's do that. Here we go. Create a new sync. Actually, it's interesting. I thought I already created, but I guess I didn't. Okay, hold on a second. Let me take a look. Sync. Back to the sync list. Back to sync list. Oh, yeah, so I did not create one. I thought I did. Okay, then maybe it's okay. Let's do that. Namespace. We're going to do, what does it say? It doesn't say here. Which built-in connector I would like to use, and it doesn't give me anything in here. Let's say Astra CDC. Sync type, there we go. We want to use Elasticsearch. Here we go. And then give your sync a name. We call it, how about this? Sync one. Let's call it one, sync one. And basically, I think that's okay. We can take the advanced settings, like instance is one. And also the processing guarantee is at least once. Like I said, these are like quality of service at most, or at least, or effectively once kind of thing. But we want at least once. We can leave these as is, right? Auto acknowledge, validate connection, force create. And then the pulsar sync configuration too. I think we don't have to worry about this part for now. And let's go over here. Connect topics. Pick which topics you would like to add as the input topic for this sync. Okay, messages published to the selected topic will be forwarded to the connected sync. Okay, so I think that's where I got to, in which I think, oh, how come these are like all uh, not the key space I was looking at? So it may not work. So let's do this one thing. Let me kind of go back in here first. Let me go back to, is it connect or topic? Let's go back to the topic in here. Let's go back in here and no, don't want to delete. Let me take a look at this one. And why have I got so many, right? And I shouldn't be having that many. Maybe at some point I need to do everything fresh again. How about that? Okay, so this is the right database. That's where I have, and I thought I had set it up. All right, let me kind of create a new. In this case, all right, let's kind of give it a try first, right? It may not work, but that's okay. So doing that, and then again, pick Elasticsearch. The name, I call it Twitch. Twitch sync. Right, that's what we thought. And the topic, we'll just use that first one. I know it's the movies and TV one. So let no movies and TV, and then use your Elasticsearch deployment to complete the field. So this is where it is now. Elasticsearch cluster the URL for it, right? So interesting. See, yesterday. Oh, how come? Okay, there we go. I think this is the same. Remember, I did a copy. Yes, that's it. So this is the one, and then the index on. So I do actually need to give an index. The connector will write the messages to the index, and so okay, that's where I think I was like getting into that. I wasn't so sure. So I need to create an index first, I think. How do I create an index? Let's go over here. Uh, edit? No. No. I think that I do need to look up just to see how I can create an index. So, uh, oh, I only have 5 days left of this. Well, okay, that's fine. Let me kind of make sure I got this working too. I just need to set an index on this thing. All right, I'm gonna look up this information on how do I indices. Okay, add content, add your document, and how do I set up an index? Oh, there we go. I think I gotta create new index. Okay, index using the web crawler. Set up a name for your index. Okay, let's say Twitch index. In Twitch, let me kind of use a good convention. It's always underscore. How about that? In index one. So, which is universal language, and then we can create it. Okay, let's see how that works. Add a domain to your index. All right, so domain require protocol cannot contain any paths. Huh. Manage my domain. Require protocol. What domain? Okay, well, I don't know. Okay, let me do this one thing. This is my oh yeah, that's right. Because I just recently purchased my domain, so I have yet to set up my webpage, and so I think it's okay too. Let's add that to my domain. Yeah, and then I can just but right now there's nothing too, so which is okay. So here's the thing. So how about my index? And now, okay, that's fine. So search index name is search Twitch index one. Okay, let's copy this and then go back to here. Actually, go back. Actually, go back to there. Index name. Okay, so this is my index name, and okay, use this to connect to the cluster. Now, oh, this is where I came get into because my Elastic account is actually a I use single sign on, so I don't know if it can handle that. That means I do need to actually set up a username and password rather than using single sign on. So with that, you have to all wait for me while I go and do that. How about that? Okay, let me do this one thing. Oops. Let me do this one thing. Let me kind of like see what I can do. Let me see if I could. Huh. I'm like surprised actually. There's a not like so. Okay, guys, I'm just gonna be like off for a little bit because I want to set up my thing here. So not sure if you're waiting for me, but I'm just gonna be offline for not exactly like offline, but you know what I'll do in this case. Isn't it fun sometimes doing these things? And let me do this one thing now. Oh, you know what? I do need to finish up some work, and so, if you don't mind, you know what I'll do? Rather than kind of putting you online, offline now, let me go and come back to this stream later, okay? And I apologize. I should have thought of it this way, but otherwise, too, I think we're very close. So I'm gonna leave it at this point and take a break, and I'm gonna come back to this stream later. Anyway, if you're watching this recording, is really not that much of a matter, but just wanted to thank you for being here because I've actually been online for like an hour and 20 minutes already. I didn't even know. If you need anything, let me know. And again, and because I need to actually do some work by 7 o'clock, so I realize I'm not done yet with that. So let me come back to you. And again, this is my Discord server. Please continue or join my Discord server if you haven't already done so. And I just want to thank you so much. And this has been fun. I think finally, I think this time I think my audio is working. So, and if anything, again, you can always tell me too. And don't be don't be strangers. All right. Okay. Take care, everybody. And I'll see you next time. Okay. Thanks a lot. And maybe I'll come back here or just subscribe to me. Then you'll receive, notification when I'm online. Okay. Take care.